Harnessing the power of artificial intelligence in this expedition to change our approach in decoding pandemics is a task worth knowing about. So, today we'll be showing you the process behind the replication of real-life environments that surround us, which made PDSIM AI for COVID a project that is capable of being a pioneer in future disease management.
So talking about simulation model, we use locations. We call them location object in the simulator to model the environment. So this location is like a building block of the environment. So we can connect different locations to build more complex environments. For example, you can see here there are rooms, so canteens, working rooms, ICUs, those kind of rooms here. So we can connect different, let's say, we can connect different working rooms and build a building, a commercial building like this. And within the building, we have different rooms in there. For example, we have 3 rooms here. And after that, we can connect different buildings to create a different commercial zone like this. So like that, we can build very complex environments using these locations. So another thing is that these locations give a structure to space. Now, because we know that a building has 3 rooms, it gives certain kind of structure to the building. Also, we can add different constraints like maximum capacity to a room or ICU, so that will come in handy. So also we can isolate different areas. For example, if you want to implement different quarantine strategies, we can isolate these locations based on the type of these locations and the location. And we can change the different infectiousness inside these locations. For example, if we consider an ICU, it has potential to be more infectious than, let's say, a park. So also we can implement different social distancing strategies. We can implement like keeping 1 meter distance in malls and like that. Also, we can design very complex environments using this location structure, location building blocks, and we'll see how to build such a complex environment. So in here, we have a small set of like a garment factory with 3 garment areas. So we can repeat these kind of garment factories to build a garment building, and it can have something like a garment canteen or something like that. And we can repeat that to build a certain sector. And similarly, we can build a big graph, a big tree that has these connected components, which gives information about the local space. So for example, this is the garment factory that we are talking about. This is the garment sector, and this is the garment canteen that I was talking about. So like that, we know that where these different locations are connected to. So if this garment canteen is here, if one person wants to go to their working place, they need to go to the garment zone and go back to the garment building and go to their working place. Therefore, building this kind of tree structure to the environment gives different benefits when we are moving these people from here and here to there. So I will give more information about that in the upcoming slides. So also, this is another illustration of that hierarchical structure that we have in our environment using the tree structure. And also we can have different interaction networks. So basically, let's call this a building, and different working places. This act as a different interaction network, and this act as a different interaction network. So basically people are more likely to move around these red square boxes. So we have implemented different strategies to like build these like confine these people to go inside these interaction networks, because this is more realistic, right? Because if we consider a residential zone, people are more likely to move around a given village, and they have more interaction with their neighbors. So it is more likely people are more likely to interact with more close neighbors rather than people very far away. So building a location structure like this tree gives that benefit as well.
We hope that this video answers your questions with regard to the mechanisms behind the design of the simulation engine. Don't forget to leave a thumbs up for this video and subscribe to our channel to stay updated on how the team at AI for COVID is reshaping reality.